Outer space looks pitch black, silent, empty, colorless. But what if I told you the universe didn't always look this way? In fact, it once glowed bright orange. Not faintly, not barely. The entire universe, every single point in every direction, was lit up like a cosmic furnace. And the echo of that ancient glow is still hitting Earth right now. Your old analog TV hears it as static. Your radio picks it up as background noise. Even a satellite dish pointed at the darkest corner of the sky can't avoid it. So why? Why does pitch black space contain the fingerprints of an orange universe? Let's dive in. If you point an old analog satellite dish at the sky, anywhere at all, you get the same mysterious microwave static. Turn it slightly, static. Try another direction, static. Look at a completely empty part of the sky, still static. This weird signal comes from everywhere, as if the entire universe is broadcasting the same message. But it isn't a message. It's a memory. This faint microwave glow is called the cosmic microwave background, or CMB. And to understand why it exists, we need to revisit a universe with no stars, no galaxies, and no atoms. Just a seething, glowing fog. Travel back 13.5 billion years, to a time roughly 400,000 years after the Big Bang. Space isn't empty. It's filled with a blistering hot plasma, a chaotic soup of electrons, protons, and light, all bouncing around like a cosmic pinball machine. At these temperatures, several thousand degrees, atoms simply can't form. Electrons instantly get knocked away from protons the moment they try to combine. And because the universe is so full of these free, unbound electrons, light can't travel very far. It scatters over and over again, trapped in the fog. If you were in a spaceship back then, you'd barely see anything. You could only see a few thousand light years through the thick, glowing haze. The whole universe glowed like an enormous, opaque light bulb, but none of that light could actually escape. Yet, everything was about to change. As space expanded, the plasma cooled. Eventually, temperatures dropped below around 3,000 degrees Celsius. This was the magic number, cool enough for electrons and protons to finally pair up and form the very first stable atoms, mostly hydrogen and helium. Suddenly, the fog cleared. With all those free electrons now locked safely inside atoms, light could travel freely for the very first time. This event is known as recombination. It was the universe's first sunrise, a final flash of brilliant orange light, blasting outward in all directions, no longer scattering off anything. And that light never stopped traveling. It's still moving across the cosmos today, and we're still detecting it. But something else happened to it along its epic journey. Space kept expanding, and as light travels through expanding space, its wavelengths get stretched. This process is called cosmological redshift. It's like taking a wave drawn on a rubber sheet and then stretching the sheet. The wave gets longer. That bright orange glow from the early universe slowly shifted. Over billions of years, orange stretched into a deep red. Deep red stretched into infrared, which is invisible to our eyes. And infrared kept stretching until it became microwave radiation. Over millions of years, the universe faded from a glowing orange to a dim red, then to invisible, and finally, to black. And after 13.5 billion years of stretching, that ancient light now exists in the microwave band. That is the cosmic microwave background, the fossil glow of the universe's first light, stretched by the expansion of time and space itself. So the universe isn't truly black. It's glowing everywhere. We just can't see it with our eyes. Now here's the really strange part. When astronomers measure the CMB, its light signature perfectly matches something called a thermal spectrum. This is the exact kind of light emitted by hot objects, like the heating element in a toaster, the surface of a star, or a superheated plasma. Everything with a temperature emits this kind of radiation. But space is supposed to be empty, cold, dark. So why does empty space hold the perfect, unmistakable signature of something incredibly hot? Because that light comes from the last moments of the primordial plasma itself. We are seeing a photograph of the universe when it was only 400,000 years old, still warm, still glowing, and in the process of forming its very first atoms. It's a baby picture of the entire cosmos. And what happened to that plasma? Those first atoms, the ones that cleared the fog and let the light escape, they eventually clumped together under gravity. They gathered into vast clouds, which collapsed to form the first galaxies, the first stars, and the first planets. Through a long, cosmic chain of stellar explosions and planetary formation, those simple atoms were forged into heavier elements and recycled throughout the cosmos. And eventually, they formed us, which means every breath you take, every atom in your body, every single molecule in your cells was once part of that orange glowing plasma at the dawn of time. You are literally built from the cooled-down remnants of the universe's ancient light. So, why does space look black to us today? Because what used to be a brilliant orange color has been stretched by 13.5 billion years of cosmic expansion into invisible microwaves. The CMB is the afterglow of the universe's childhood, still here, still detectable, and it still carries the blueprint for the large-scale structure of the cosmos we see today. Space isn't colorless. It's just that its true color has been stretched so far and has become so faint that our eyes can no longer perceive it. In a way, black is the new orange. Thank you so much for watching. If you enjoyed this journey back to the dawn of time, please consider liking this video and subscribing for more cosmic stories. See you next time.